So as you turn the frequency up, you can see that the waves on the scope get closer together. That corresponds to a shorter time between the peaks, which means shorter period, and the frequency is proportional to the inverse of the period, 1 over the period. And as you go to higher frequencies, you can also hear that the tone, the pitch is going up. So we get a little, have to probably go up to a little higher. Time division there. So the pitch increases as the frequency increases. And likewise, when I go down to lower frequencies, you can hear that the pitch decreases. So lower frequencies, lower note. So the terms lower and higher actually are appropriate because they refer to the frequency or the number of times per second that the speaker is going back and forth, or the number of times per second that the maximum pressure hits my ear. And so we have the oscilloscope hooked up to the signal generator so we can see what's coming out of the signal generator. So it's pretty much a pure tone. Now, if we want to listen to a more complicated waveform, we can listen to 2 tones at once. So let's try, how about 220, that's an A, 220, and 330 is an E. If I detune it a little bit, you can hear the beats. You can see a complex waveform.
So this is the beat between 220 Hz and 217 Hz. So we should have a beat frequency of 3 Hz.
3 Hz. So in 1 second we should see 3 beats.
Right.
1, 2, 3. So I can hear in my ears when the beats slow down. Closer and closer to the same frequency.
This is the beat frequency between the 2 tuning forks.
Yeah, both close to C. 221. That's 660. And then 880 would be an octave above
Oh.
440.
A440, the International Orchestra tuning.
So that's another. So we went from 110 to 220 to 330 to 440. So 110 to 220 is an octave, 220 to 440 is an octave, and then 440 to 880 is an octave. And then the steps in between, we got a fifth, and then I think a third above that, and then seventh above the fundamental.